Hello everyone. Welcome to my YouTube channel. In today's video we'll talk about trigonometric ratios. In this tutorial we'll talk about the prerequisite knowledge required to understand the trigonometric ratios, and then we'll talk about the structure of right-angled triangle. After that I'll introduce you the concept of trigonometric ratios, and in the end we'll solve few problems related to trigonometry. So let's begin the video. Now we'll talk about the skills you are required to fully perceive the concept of trigonometric ratios. You must understand the composition and structure of a right-angled triangle and how Pythagoras' theorem works on a right-angled triangle. Also, you need to have a full understanding of the angle properties of polygons, especially triangles, and algebra. I have already made a detailed video on the structure of right-angled triangle and Pythagoras' theorem. The link is in the description below. Here we will just recap the right triangle structure in terms of trigonometry. We know that there are two perpendicular sides in a right-angled triangle, called height or perpendicular and base, and a hypotenuse which is always opposite to the right angle. Let's say we have an angle theta at the bottom right corner of this triangle, then the position of perpendicular or height will be opposite to the angle theta. Hypotenuse will always be opposite to the right angle of the triangle and will never change its position. The position of the base is very easy to determine as it is always the side where both angle theta and right angle lie simultaneously. Now if we change the position of angle theta, the position of perpendicular and base will also be changed, as perpendicular is always opposite to the angle theta and base is on the same side where angle theta lies. The only thing will remain unchanged is hypotenuse. Trigonometric ratios. Sine, cos, and the tangent are trigonometric ratios that relates the angles and side of a right-angled triangle. We can apply these ratios to know the unknown sides or angles of a right-angled triangle. Sine theta is the ratio of the perpendicular or opposite side to the hypotenuse of the triangle. In sine theta, the perpendicular or opposite is divided by the hypotenuse. Similarly, cos theta is the ratio of the base or adjacent side to the hypotenuse of the triangle. In cos theta, the base or adjacent is divided by the hypotenuse, whereas the tangent theta is the ratio of the perpendicular or opposite side to the base or adjacent of the triangle. In tangent theta, the perpendicular is divided by the base. To calculate the unknown angles, we divide any of these ratios and take the inverse of sine, cos, or tangent theta accordingly, and also to calculate any unknown side lengths, we multiply or divide the sides with the cos, sine, or tangent thetas. Here we will solve a couple of problems to practically understand the concept. In this problem we are given with perpendicular 6 meter and hypotenuse 8 meter, and we need to find the angle theta. As we have learned that the ratio of perpendicular to hypotenuse is sine theta, we will apply it and divide 6 meter by 8 meter and take the sine inverse, which will gives us our angle 48.59 degree. In the second problem, we are given with perpendicular 8 meters and an angle of 60 degrees. Here we need to find the hypotenuse. Let's assume the hypotenuse is x. We know that the ratio of perpendicular to the x is sine theta. We will apply it and will make x the subject. Then we will divide 8 meters by sine 60 degrees and will get x equals 9.24 meters. In the third problem, we are given a base 5 meters and an angle of 65 degrees. We need to find the hypotenuse. Let's assume the hypotenuse is x. We have learned that the ratio of base to hypotenuse is cos theta, so we'll apply it and make x the subject, then we'll divide 5 meters by cos 65 degrees to get x equals 18.93 meters. In the fourth problem, we are given a base of 5 meters and a hypotenuse of 12 meters. Here we need to find the angle theta. Since we are given the base and hypotenuse, we will use cos theta to find the angle. We will simply divide the base by the hypotenuse and take the cos inverse to get the angle of 65.38 degrees. In this problem, we are given with perpendicular 9 meters and base 8 meters. Here we need to find the angle theta. We have learned earlier that the ratio of perpendicular to base is tangent theta, so by applying tangent theta, we can divide 9 meters by 8 meters. And then take the inverse of the tangent to get the angle of 48.37 degrees. In this second last problem, we are given with perpendicular 12 meters and angle 48 degrees. Here we need to find the base. Let's assume the base equals x. By applying tangent theta, we can make x the subject and divide 12 meters by tangent 48 degrees to get 10.80 meters, which is the length of the base. In this last problem, we are given the hypotenuse of 12 meters and the angle of 60 degrees. Here we need to find the perpendicular. Let's assume perpendicular equals x. The ratio of perpendicular to the hypotenuse is sine theta. By applying sine theta and making x the subject, we will multiply 12 meters with sine 60 degrees to get 10.4 meter, which is the hypotenuse. This is all, folks. Thanks for watching the video. I hope it will be very informative to you. Please do not forget to like my video, subscribe my channel, and share it with others. Thank you.